Deconstructing clean code, the unseen costs of software purity. Everyone in software engineering talks about clean code, functions that read like poetry, layers that are perfectly abstracted, systems that are, well, flawless. And yet, for every perfectly pure codebase you admire, there's often a hidden cost. Today, we're going to dissect clean code not to attack it, but to understand its unseen consequences. The subtle debt, the mental load, the complexity that grows quietly behind the scenes. Because sometimes the pursuit of perfection isn't free. The promise of clean code. Clean code at its heart promises maintainability, readability, and fewer bugs. Principles like solid, dry, and meaningful naming conventions aim to make life easier for developers both today and in the future. On paper, it's perfect, elegant, logical, beautiful. But what happens when we follow these principles too rigidly? When abstraction and purity become the main goal rather than the tool? For example, imagine a team building a payment system. They implement every possible abstraction, every generic interface, every design pattern recommended by books and mentors. Months later, adding a simple new feature requires navigating a maze of classes, interfaces, and factories. Pure code becomes a cage. The hidden costs of purity. Here's the uncomfortable truth. Clean code has costs you can't always measure. Cognitive load. Every abstraction, every generic function, every principle adds mental overhead. Your engineers are constantly juggling rules, layers, and constraints. Maintenance burden. Clean code often becomes fragile over time. A small change in one layer can cascade into dozens of other dependent modules. Technical debt in disguise. Oddly enough, over-engineered, perfect abstractions can create hidden debt. When code is too rigid, small business changes or feature requests become monumental efforts. Clean code doesn't automatically mean easy code. Sometimes it's elegant, but hard to work with. When purity backfires. Let's get real. Clean code can backfire. Teams spend hours trying to fit a new feature into a perfectly abstracted architecture. Engineers argue over where exactly something belongs. Deadlines slip. Frustration rises. The irony? A messy, pragmatic solution often ships faster and survives longer than a perfectly pure one. Perfection pursued without pragmatism can slow teams down, increase cognitive fatigue, and create fragile systems that resist change. Real-world analogy. It's like building a museum of code. It looks beautiful, visitors admire it, but try hosting a party in it? Suddenly, that elegance becomes a constraint. The cognitive load problem. Human brains can only juggle so much complexity. Layer upon layer of abstraction, naming conventions, and patterns adds invisible weight. Even senior engineers feel it. Burnout, slower problem solving, increased errors. These costs are real, but rarely quantified in discussions about clean code. Software isn't just about rules, it's about humans writing, reading, and maintaining those rules. Finding balance, pragmatic clean code. So how do we navigate this? The solution isn't abandoning clean code. Principles are valuable. They give structure, readability, and safety. But we must apply them pragmatically. Abstractions only when needed. Don't generalize for virtue alone. Favor simplicity over elegance. Readability and maintainability come first. Refactor for clarity, not for perfection. Improve code incrementally. Don't chase an unattainable ideal. Balance exploration and execution, Some parts of code need experimentation, some need stability. Clean code should serve humans, not constrain them. The human element. Software is written by humans for humans. Rules, patterns, and purity matter, but only when they enhance human understanding and productivity. Clean code should not be an idol. It should be a tool, a compass, not a cage. When we respect the human element in engineering, we create systems that are maintainable, scalable, and adaptable without drowning in the unseen costs of uncompromising purity. Takeaway. Clean code is beautiful, principles are powerful, but perfection pursued blindly can become expensive, fragile, and exhausting. The real mastery, knowing when to be pure, when to be pragmatic, and when to prioritize human understanding over abstract ideals. Think of clean code as a guide, not a law. And remember, code is ultimately about people. If this made you rethink your approach to software design, hit that like button, share your experiences in the comments, and subscribe for more deep dives into the hidden sides of engineering.